Hi, my name is Ryan Champlin. I'm Senior Director of Product Marketing for SAP HANA. And welcome to my basement here in sunny Wisconsin. Definitely not where I expected to be for TechEd 2020. And let's get started with our session today, which is optimize your data tiering strategy for SAP HANA with persistent memory. So let's start by discussing some of the data management challenges organizations are facing today and trying to derive business value from all the data we have laying around our organizations. We're all familiar with the increasing amount of data that we have available to us. However, data is more diverse, composed of different data types and different structures, from relational data to free-form text, logs, spatial or graph data, JSON, or maybe some old XML documents that are still laying around. And we have a lot of new demands on the data from our organizations as well, such as supporting advanced analytics and machine learning. And with most organizations making significant investments in cloud applications and technology for many good reasons, this has also increased data management complexity by creating new silos of data across data centers and different cloud platforms. In other words, my data is all over the place and more difficult to access than ever. How do you manage all of this data in a way that makes it easy to access for the right consumer to get value from it, while at the same time reducing management and storage costs to accelerate the time to deliver solutions to the business? So these issues cannot be solved simply overnight. There's no silver bullet here, don't get me wrong, but 10 years ago, SAP developed SAP HANA to help organizations break down some of these silos. And we've really taken that to the next level now with the release of SAP HANA Cloud earlier in 2020. So the fragmentation of data across specialized data platforms, services, and applications, especially in the cloud, requires a lot of complex integration methods and increased requirements for specialized skills to work with a lot of different technologies. And data has to be copied, moved, and constantly aggregated, hampering the business's ability to be quick and agile on its feet, and exposing data to increased security vulnerabilities and preventing timely decisions and action. So what are some of the ways HANA in general has helped provide a solution to break down some of these silos? So first off, we provided a way to support transactional and analytical workloads on a single platform. So enabling everything from embedded operational analytics directly on your transactional system. So this is really possible because of HANA's in-memory capabilities and the ability to perform complex analytical operations in real time. Second, we have a lot of multi-model capabilities, enabling you to store and easily combine different types of data from relational, spatial, graph, and document stores. This includes built-in machine learning capabilities, so no need to extract data to another tool set to gain deeper insights. All in one platform with your data in one place. But does that mean you're realistically going to consolidate all of your data into HANA, for example? No, not at all. So we have advanced data virtualization capabilities to help provide a single canonical view or data model to consumers across many different data sets. Those data sets might live in HANA, and they might live in other applications or data stores in your enterprise. So this ultimately helps provide that single pane of glass to look at all of my data across the enterprise, connecting it where it lives, be it in a HANA or some other system. So already over 31,000 direct customers have taken advantage of these capabilities of HANA. And today I'm going to talk about HANA support for Intel Optane Persistent Memory and how you can use that technology with HANA to manage more of your data with a lower TCO while also increasing your business agility. So let's dig a little bit deeper now. Let's start with what is Intel Optane Persistent Memory. So it's a new type of memory that comes in the same DIMM form factor as DRAM. But as the name implies, there's a difference here. It provides data persistency, unlike DRAM, if used in a specific mode of operation. We'll talk about that in a little more detail. So HANA is the first major database optimized for persistent memory using AppDirect mode, which is provided by Intel and helps ensure that all the features and capabilities of persistent memory can be realized with HANA. So the obvious advantage here is that the data does not disappear when the power goes off or when HANA restarts. This translates into improved business continuity and also almost instant in-memory performance at startup. So for example, Evonik Industries saw a 17 times improvement in HANA startup time when using Intel persistent memory compared to a traditional system with just DRAM and SSD. This is the amount of time that it took for data to be fully available in memory. But there's more here. Persistent memory has a higher memory capacity than DRAM overall, and also helps deliver a lower TCO because of cost comparison differences between DRAM and persistent memory. With persistent memory, HANA can potentially manage larger data volumes at in-memory speed, potentially up to 4.5 terabytes per CPU. So to take advantage of this technology, you need to at least be on HANA 2 SPS 3. And the best part is no changes are needed to any of your applications running on HANA at all. So let's take a look at one example here. This is a 2-socket system. And with traditional DRAM, we'd have, say, 3 terabyte system on the left-hand side here. And if our workload-based sizing for HANA allowed, we could potentially have a scenario such as that on the right-hand side, where we have a 2-socket system with a total of 7.5 terabytes, or a 1:4 ratio of DRAM to persistent memory. So back in early 2019, when Intel released persistent memory to customers, with this specific example, customers could realize as much as 20% savings on this particular system on the right, while also enjoying 150% increase in capacity. So keep in mind, HANA support for various DRAM and persistent memory ratios highly depends on your use case and workload. And the overall TCO will be based on your individual scenarios. So later on in this presentation, I'll share some examples from our customers as well. So HANA provides some advanced data tiering capabilities to help balance your performance needs, storage, and cost requirements. And persistent memory fits right into this particular conversation. So persistent memory is one technology that we have to help increase our ability to store more data in memory for improved performance, but at a lower TCO. And we also have technologies like native storage extension and extension nodes to allow you to scale additional storage up or out, leveraging both memory and disk, commonly for warm data management scenarios. We also have other options for older, less frequently used data, for cold storage, for example, such as the new HANA Cloud Data Lake, cloud storage options, the ability to use Hadoop, Spark, and HDFS, or even SAP IQ, all depending on the specific scenarios of how you're using HANA. We also have another TechEd session that I highly recommend that you go to that covers a lot of the details of all of these different data tiering options. That session is DAT 105. So let's dig into a little bit more detail now. We've been working with Intel for many years on this technology to ensure that we can deliver optimum value for all of you and our customers. So let's discuss a little bit more of how we did that. So persistent memory is a memory technology that in general is slower than DRAM, specifically when it comes to write operations as compared to read. So HANA's unique in-memory architecture lended itself perfectly to getting the most value out of persistent memory without major modifications on the software side. To provide all those benefits, we had to make some changes in terms of how we control how we use DRAM and persistent memory, which was enabled by Intel's App Direct mode. So we continue to leverage DRAM for volatile operations, such as our working memory for ongoing queries, calculations, and most write operations, while storing the more static data, which accounts for usually 95% of all data in HANA systems, in persistent memory. Thus, we're able to deliver DRAM performance while still supporting full ACID compliance. This unique architecture enabled HANA to seamlessly manage all of your data for optimal cost and performance benefits while still having memory that supports persistency. And that persistency means we no longer have to load data from traditional persistent storage, such as disks, back into memory at startup, thus improving business continuity for planned maintenance and HADR scenarios, because we now have dramatically faster data loads at startup. All right, so let's talk a little bit more about Intel's modes of operation. So one is basic memory mode that you see on the left-hand side here. This is what most software vendors are using today. The reason for that is the software doesn't have to change to leverage persistent memory with this mode. They get all the benefits, but they don't get all of the benefits of persistent memory. You'll get larger memory capacity, and the DRAM acts as another cache, so it doesn't increase the overall memory capacity in this case in total. Also, you do not get the data persistency characteristic with memory mode. So any data in persistent memory is still volatile. Certain types of operations on the data as well in persistent memory will also experience a performance hit compared to pure DRAM. So another mode we want to talk about is Intel's AppDirect mode. So HANA is the first major database optimizing its software leveraging this mode. This gives us full control in the software of data placement within DRAM or persistent memory so that we can optimize to provide near DRAM performance and take advantage of the full memory capabilities of persistent memory. And of course, the all-important persistent characteristic that you would expect to have is available in this case. So our competition would have to re-architect many of their applications in order to take full advantage of the persistent memory capabilities using AppDirect mode that we have available in HANA today. So we've talked about how HANA is highly optimized to support persistent memory with AppDirect mode, but recently we announced some additional support for the other modes of operation that Intel has, but specifically only for non-production use cases as of today. These are mixed mode and the memory mode that we just talked about. So these additional modes enable HANA customers to have more flexibility in how they leverage DRAM and persistent memory based on the different types of workloads or use cases after the purchase of hardware has been made. So it's not always possible for you to predict all the future workloads you might have for HANA, especially after you've made that initial hardware purchase. And so this opens up some additional capabilities and flexibility for you to tweak how HANA leverages these two different types of memory based on your changing needs. It's also very important to know that as you increase the ratio of persistent memory to DRAM, you'll realize a higher TCO because of the cost differences between persistent memory and DRAM. However, you'll need to make sure that you perform workload-based sizing to ensure you have enough working memory versus in-memory storage to support your specific workloads. Now, we haven't really talked about mixed mode much yet, and I don't want to overcomplicate this too much, but to try and keep it simple, mixed mode basically enables you to configure within the BIOS a logical memory layout that allows you to adjust the amount of persistent memory that's treated like DRAM or volatile memory for the operating system versus persistent memory that's used for in-memory storage, such as for the HANA main store. This option provides improved cost optimization for storage with easy support for larger DRAM to pure persistent memory ratios, and still enables fast restart times with persistency. And it's highly flexible to allow you to change that logical mapping of DRAM to persistent memory ratios as your needs and workloads change over time. So this is a nice visual to kind of summarize the benefits of all the options that we offer now. So high performance, persistency, and improved TCO compared to standard DRAM with AppDirect mode. And then for non-productive systems, you can also have more flexibility in how you adjust your hardware investments in memory and how they're used based on your use case you have for HANA. So still highly cost optimized, very flexible, but you may lose some of the benefits of persistency and near DRAM performance, depending on how you configure things with mixed or memory mode. If you're interested in exploring this new option that we have a little bit more with your HANA investments, feel free to contact me with the information that I give at the end of this presentation. All right, so lastly, I'd like to share a few customer examples. First is Canadian Pacific, a leading railway in North America. They run all their mission critical SAP systems on HANA and recently invested in new Cisco infrastructure, which included Intel Optane Persistent Memory. So they used a 1:2 ratio of 3 terabytes of DRAM to 6 terabytes of persistent memory. And in making this investment, they developed a cost model, which showed that they had a 20% cheaper per terabyte cost to store data in HANA compared to other leading databases that they have in-house today. And now they have 4 to 5 times more storage capacity than before with an overall lower cost. And because of the persistency capabilities they have now, this significantly improved their business continuity as they've seen 8 times faster HANA restart times to where any scheduled or unplanned downtime for HANA virtually has no effect on the business. Also, they've been able to leverage the improved efficiency of HANA with persistent memory to simplify their landscape with a 70% consolidation of their SAP application instances and reducing the number of HANA nodes to support these applications from 22 down to 7 by the end of 2020. In the end, all this simplification has enabled them to deliver 8 times more innovation to the business. This is new enhancements, new features, new solutions at an overall lower cost than before. Next is one of our early adopter customers, Geberit, a leading European provider of bathroom and sanitary products. So Geberit has had to manage a steadily increasing amount of data driven by acquisitions and continued growth in their business. And they were looking to find more cost-effective ways to increase the memory capacity of its servers and reduce downtime without expanding its server landscape. So Geberit worked with us to test HANA on persistent memory, and they ended up seeing a 400% improvement in data load at startup. And they also saw no noticeable performance degradation due to the use of persistent memory because of HANA's unique architecture and how we've been optimizing it for persistent memory. They tested over 5.5 million different statements with no noticeable performance difference. So they see HANA as HANA's industry leading support for persistent memory as a key way to continue to grow their business and be more cost effective. Finally, we have Evonik, which is one of the world's leading specialty chemical companies headquartered in Germany. Our partner Accenture teamed up with Evonik, working with Intel and SAP to create a proof of concept in Accenture's global HANA Center of Excellence. So Evonik utilizes HANA for real-time analytics and reporting to better understand customers and the complex supply chain that they have to support them. But they really have a huge volume of data that they need to analyze, and it continues to grow, and they need a solution that helps them work more efficiently with large data sets and with less server downtime for their HANA systems. So when they did their testing, they saw a 17 times improvement of data load at startup with 1.6 times faster system response time for its user and an overall 30% reduction in run costs. So some of the key benefits that they see are shorter maintenance windows for HANA for patching and configurations, lower total cost of ownership with reduced infrastructure, less server downtime for its HANA systems, and increased productivity with faster start times. All right, and if you have more questions in terms of trying to get more details on this, please go to sap.com/Intel. We have a ton of great content that dives into what we've done with Intel and persistent memory with SAP HANA. We also have another session on data tiering, as I mentioned, and Intel will be delivering a session as well, diving into some of the details. So please make sure to attend those as well. And then lastly here, to continue your learning experience with TechEd in 2020, continue to use a lot of these resources that we have to learn more about the great products from SAP as well as from our partners. And lastly, if you have any more questions or are interested in some of the new offerings we have around the different modes of persistent memory, feel free to send me a message on LinkedIn using the URL that I have here. Thank you so much for attending today and enjoy TechEd 2020.